Donnie? Oh, wait.
Testing, 1, 2. Perfect.
In a world where drawing site plans
So you're going to go, and then after you get done, then Kirby, you're going to go after Timmy. with our August version of Revit DC. Thank you guys for coming out. I really appreciate it on this Tuesday night in August to share the evening with us. CAD Microsystems obviously is the sponsor of Revit DC, and we do these user group meetings every other month. Do we have anybody that's here for the first time that's never been to a user group? We got one. Welcome. Welcome. I don't know who invited you. We got two. We're glad to have you here. Revit DC is really meant to support Revit users. And we have 4 groups running right now that CAD Microsystems supports. One in Baltimore, obviously DC, one in Richmond, and one in the Raleigh area. And so the reason I mention this, if you have any people that are interested in the topics that we talk about tonight, we talk about similar topics in each one of these cities every other month. So, and I also have an announcement to make that we will be starting on October the 16th, a Revit user group in Charlotte, North Carolina. They chose the name Queen City because Charlotte was Queen Charlotte, and they call it Queen City. It's the way it's branded down there. But nonetheless, we will have 5 user groups in 5 cities, 30 meetings a year, and we hope to be recording many, if not all of those meetings for your pleasure, for your evening entertainment after you get home, or if you have insomnia and want to go to sleep, you can watch these things. So Donnie's in the back of the room there, recording these meetings right now, and he'll be recording the one tonight. So really, what is this all about? It's about what's going on right now. It's about you all meeting each other, congregating and talking over issues that you have at work or maybe personal, but connecting, because you all are the ones that are really leading this community. And it really is a community of people that move this technology forward. This is all really guided by a board of advisors, and the board of advisors is a group of people that reviews each one of the presentation submissions that we have and decide what goes on in the next meeting and meeting after that, so that you all get relevant topics to come see it in the evening. It's all driven by these surveys. We have it on the table. You can fill it out as we're talking in the meetings. If you have a topic you'd like to see or you'd like to present, please fill that out. We'll review that a week from each meeting. The advisory board will, and we'll decide on which is the most appropriate for each meeting. So this is what we're going to talk about tonight. We're going to talk out first with a built recap. I went this year. I went to the early built conferences and hadn't been for a few years, and it was really refreshing to go to Seattle this year and see the conference. And many of the people, how many people here went to Built? Anybody in the room here? We got a couple of them. We got 4 or 5, right? And really that's what we're here to do, is to bring the best of Built back to you, bring the best of that conference, bring the best of the ideas so that we can all share back in our own individual communities. And really what Built is doing is very, very similar to what Revit DC and all of our user groups are doing. Let me go back to the beginning there. The very beginning. So what is Built? Built is really, it started out as the Revit Technology Conference. The Revit Technology Conference was started by these crazy Australians, a guy named Wesley Ben, and a group of folks that in Australia started doing events. And since then, they've done all this list of events that you see here. Right? This started in 2011 in the United States, but these are events that are all over the world. If you look at the cities that are going on here, this is all over the planet. So what this does is this connects you with all the other people that are doing what you're doing, or your compatriots around the world, solving the problems so that we can digitally design. And so what they did, design and build and make things better. So what they did was they changed the name of the conference to the Design Built Environment Institute, or DBEI, which is really the governing organization of all this. And why did they do that? We got one screen that's not working over here, but I'm not going to focus on that. We're going to focus on this. Why did they do that? Because I think the Autodesk police didn't like them using the Revit name, and they chose to come up with a different one, which is really all about the digital built environment. How are we dealing with all these digital information that we're creating, that we're authoring, that we're using, and how best to apply this to the industry. So what happened is the DBEI puts on the Built conference, you see down there to the lower left, which is really the biggest conference, and they have these in each continent across the world. And then they have the hackathons, and they have the DTS conference day-to-day, and the Building Content Summit. So really, what they're trying to do is to split it out into each areas of data, of what's going on with content, of what's going on with data sharing, and then a hackathon. And I'd also like to have a big round of applause for the winner of the hackathon, Tim and Hazel. Please, thank you. Straight from DC, and all the people in the United States that came to the Built conference that participated in the hackathon, there was only one winner, and it was Tim. And so, and he can talk to you a little bit about how he achieved that accomplishment. But it really speaks to that we're a part of a community on this planet that's really using this digital information to really design, build, make things greater. So it is a very significant thing that we're doing. So who is the DBI for? It's really for thought leaders, practitioners, people that really want to push this technology forward and have a passion for it. And you all have self-selected yourself because you're taking your Tuesday evening to come out here and spend it doing this tonight because you're interested in this stuff, and this is really what is moving the industry forward. So I just want to talk a little bit about the Built conference. It was in Seattle. Each day they had different things going on. Obviously, the Built conference is a bunch of sessions on design technology and how it's all being used. But there's a hackathon. There's the DTS, the day-to-day in building. So DTS is really the Design Technology Summit. Is really to bring together people. It's an invitation-only thing for only 40 registrants. And it's a really small group of people that are really trying to solve big issues that really, come to the fore with larger firms first rather than smaller firms. And then there's day-to-day. And it's specifically focusing on how people are using the data in the data ecosystem, how you putting this data together, where is it stored, what are the standards about all of that. These are really minute things that really apply to a very small number of people on the planet, but they all get together in one place to discuss this. And there's the Building Content Summit, which is really about inviting the people, the manufacturers, the people that create building parts, and how do you digitally represent those things so that people will use them when they're designing and creating and building buildings in these models. And then there is Built, which is the overall conference. And the Built conference is really a collection of what I'll term the smart kids in their design or Revit world, if you will. And so a lot of these topics are not really basic topics that you're going to see. They're more advanced topics than you would normally see at a conference. So, and I'd also like to mention that at the Built conference, there was 9 people that are associated with, there's 9 presentations that were done. Purvi actually did 2 of them at the Built conference that were represented from people from the Revit user groups that CAD Microsystems sponsors. And here's a list of kind of the names. And really, we're drawing from this to make sure that you all get the sessions that you want. So, the people that are presented at Build, you most likely see them at one of our user groups. So here's my real short and brief, and I think Tim is going to touch on this too. But one of the things, my big takeaway from the Built conference was these guys at TestFit.io. So what is TestFit.io? Anybody familiar with these guys? TestFit.io? Okay. If you're not familiar with them and your firm deals with developers, you want to know who these guys are. This is the first real, live, usable Forge application that I've seen. We've talked to you about Forge in the past before. I think you're all a little bit educated on it. TestFit.io has an application that is usable right now that kind of really blew my mind, and Timmons too as well. So what this does is it's a configurator. So let's just say you have a site and you want to say, hey, I want to have 235 units on that site, and it's a multifamily unit, and I want to go through different configurations and figure out how much will fit on the site, and based upon the parametrics design. So really what this does is allows you to parametrically test fit a site to see what you can fit on that site in these different options. So normally a designer would do this and submit those to a developer. Now a developer can do this, or a designer can use this tool to do the test fit. So Tim is going to run a short video here, and he recommended that I don't use the audio, but I like the audio. So let's see if we can hear it, if this comes on. So really what this is It may or may not be working. Well, certainly I think he muted the audio. So what this does is it's very hard to see what's going on here. But if you take a look, if you go to the website and you take a look at what's happening here, what they do is there's parameters on the side here, and then there's feedback down here on what it's measuring. So it actually gives you quantity counts for how much space is inside each one of the buildings, so that you can estimate how much this is going to cost and whether your schemers are going to work or not. So real time, and this is not sped up. This is kind of how it works when you go use the site. If anybody is, like I said, dealing with developers that are trying to test fit sites, this is a way to do it. So this is moving really fast. The audio would tell you what is going on here, but the audio is not working right now. But I just want you all to know that if you want to see a Forge application, go to TestFit.io, go to their website. You can schedule a demo or look at what they're doing here. And this is for real. This is generative design. It's generative design because it generates many, many different options for you. It'll generate 1,000 options you want, but 1,000 options you want, but nobody wants to go through 1,000 options. You only want the top 3, and this is what this allows you to do, is get down to the top 3 really, really quickly. And guess what? At the end, once you're done dealing in this Forge environment, right, of test fitting your building, then you can output this to AutoCAD, to Revit, to SketchUp, or whatever you wanted, whatever program you want to. So, and the second big takeaway that I had from the conference was there was a presentation that was done by Turner Construction. And Turner Construction, a guy named Derek Zero and a bunch of his teammates put together a presentation where they were showing how they were using virtual reality. And they posed a couple scenarios. So what they did was they took the building model, they modeled it up, but they didn't model it down to specific level of details. They modeled level of details about how the people that were installing it in the field would want to see it, right? So they stripped out all the stuff and they really made it very visual, so that people, before they ever went on site, before they ever started the project, that they could walk through it. And they actually did this, put these glasses on. These are people that were installers and mechanics that were really kind of like interested in what was in the virtual reality of the site. But more so, what they did was they took this and they took it to the permitting authorities. And they went to the permitting authorities and they said, hey, the building's not built yet, but can you, the plumbing inspector or the electrical inspector, can you please walk through the model with us so that we make sure we get it right before we ever start building, collapsing the time before the building gets its certificate of occupancy. So this is I don't have great images here because I tried to download them. They didn't turn out well, but it was a very good use of virtual reality to help speed up the project. So anyway, that's a little bit about CAD microsystems and our user groups and what happened at Built. And Timon, why don't you take it from here?
Thank you, Jeff. Mm-hmm. All right, so Jeff already stole one of my big thunder shots, and that was the TestFit.io thing. But one of the things I wanted to say is I'd seen generative design before at conferences, more as a buzzword, more as things that were happening, going to happen in the future. Now, it's not here today to take over everything, but I will say that it's part of what I'm calling augmented design. I think we currently live in an era, a coming era of augmented design where we are using virtual reality, where we're using generative design to help us assist. And those of us that will adapt to this augmented design where the machine is doing some of the design and the human is doing other parts are really going to be able to take advantage of things. So I'm going to talk about 4 different areas of the conference. First, I'll talk a little bit about the hackathon and what that is. I'll talk about owners' expectations, really short. We'll talk about working with data, and then machine learning. I'm going to skip the part about generative design. So the pre-conference hackathon. For those who have never been at a hackathon, you do not have to know how to code to go to a hackathon. Our team was 5 people, so the 5 of us won first place, not by myself, just to be totally clear. We were 3 people from MBBJ, 1 person who was a MEP designer in Australia with BIMtelligence, and then myself from Silman. And we decided to look at a very small problem. What do you do with a clash after Navisworks has already been run and you want to process the clash further? And our result out of the hackathon together, again, these are kind of 2 project manager people and 3 people who did the coding, all working together to come up with this in 2 days, was we created a web application. Again, this is just a kind of a prototype, so it's not really released out completely, but a web application where the people who are going to make the decision about who's going to decide, who is going to solve this clash, they can decide the clash, they can pick the solution. So they might say, for example, it's most expensive to cut through the beam. Surprise, surprise. It's less expensive to reroute the plumbing. But maybe at a different phase, it might be different, or maybe if it's a different type of, if it's a different duct or something, then routing it through the beam might be more helpful. So during the clash detection or post-clash detection conversation, they would select the optimal solution in the web app because they're not usually going to be working in Revit. And then back home, the people who are receiving the data, so for example, an MEP consultant would just receive the clashes that had been decided are going to be solved by MEP. The structural engineer would only receive the clashes that were decided would be solved by the structural engineer. And then we kind of put together an update model, and it would update the model in the way that the clash was decided by the project managers were going to be solved. So kind of a prototype, but what I learned through this exercise was that this idea of, again, augmented design, or we actually use some generative design ideas about how to route the pipes, it's really here, and there are real applications that can be applied. So going on from the hackathon, I went to a few presentations from owners. One was during Data Day, and one was during the main presentation. And both of them really said, we want data. We want good data, but they wanted it in different ways. So the one presentation was by the Alberta Infrastructure, so the entity that runs all of the government infrastructure inside Alberta, Canada. And they have a great BIM deliverables document. Highly recommend writing it down right now, going and checking out Alberta's BIM deliverables document, because they went 4 years ago from having one line, do BIM, to actually having, I think they have 20 pages of what they expect when you're doing BIM on their projects. I might have some recommendations for them for how they can adjust it, and they're working on it, but that was really interesting. And they said, you know, if I give my operations guys a model, they are like, what am I supposed to do with it? But if I give them a Kobe document, they're like, oh, that's amazing. That has all the information I need, and they wanted a spreadsheet. So it was interesting to hear them say that. There was another group, Willow, that is currently working on digital twins. And digital twins is this idea that there is a virtual representation of something real. And so in this case, a virtual representation of the building. They were using BIM 360. So for those of us who are working in BIM 360, they were pulling your models directly out of there. And then they were putting usage data on top of that, so that the owner could kind of review the models, their buildings, and they would kind of connect all of their buildings together in one model. So it was really interesting to see the two different ways that owners are looking at it. But in the core of it, they're looking for data. And really, our models are data. They're represented. They have a geometric representation. But really, that's what they are. Heard a lot about data extraction. Everyone's using dashboards. Dashboards for this, dashboards for that. You don't have to go and create your own dashboards. There are a lot of entities out there. But when we're working with so much data, we have to create a human-readable way to look at that. And I think Richard has an example of that where, where he's looking at journal files, which are huge in mass, but he has a visual way for a human to understand what are they looking at. And so same here, model health, whether it's the BIM maturity of a project or a project team, all kinds of different things. Geometry and data transfer has been something that's been at these conferences for years. A few years ago, flux was a big buzzword. The one that I saw at this conference was Speckle. So it's interesting. Speckle has the ability to not send the entire model to the rest of the players in the team, but to just send some key control points. So for example, if I am the structural engineer and I'm developing the exterior facade, I really only may need the exterior mass of the building. I might not need all the components. I might need information about some of the structure, some of the floor plates, but those are just key control points that can be exported and then downloaded on the other end and processed in the way that they're going to use it. But not sending a full model, but just kind of the parts that are pertinent to different entities. And I thought that was interesting. It works with all kinds of applications. But wait, Rhino. Am I allowed to say Rhino at this user group? So I'm going to talk about Rhino because Rhino has just redeveloped their entire application to work on top of Revit. So you can now open Rhino on top of Revit. All of the Grasshopper stuff works on top of Revit. It's in beta, but I believe in the next year or so they'll release the next version. But not just Revit. You could put Rhino on top of anything. Maybe on top of Outlook. Or maybe on top of Excel. Now, okay, that might be a little bit too extreme. But just to prove the concept, here's a screenshot of my Revit. And there's Rhino running inside of Revit and the full application. The last part that I'm going to talk about is buzzwords or reality. And the two words I was picking up on, one we already talked about, and that is generative design. And the second is machine learning. I went into this conference with a very specific view of machine learning, but realized that our industry currently is using it in slightly different ways, and there is machine learning that's happening today. So there were two different talks I went to. One was focused on machine learning inside of Dynamo, and one was focused on machine learning inside of Grasshopper. Now remember, Grasshopper now is going to work on top of Rhino, on top of Revit, so they're all applied. But the Lunchbox add-in that I went to on top of Grasshopper also works inside of Dynamo. So to boil down what is machine learning at the very basic is creating a formula from a set of data points. It's basic statistics. We think of it as this really complicated thing that can never be attained, but at the very, very, very basic level, if you've ever used Excel and you've ever in there created a line to fit any data points, that is a very basic form of machine learning. It creates a formula, and then it uses that formula to make guesses about the future. So in this example, right, it might be, I'm going to nerd out here as an engineer for a minute, x equals y, and that was the guess that the computer came up with. So if you plugged in later on 5 into it, it would tell you 5. If you plugged in 10 into it, it would tell you 10. So that's just the basic formula. But if instead of numbers going into it, you can input features. So you could say, for example, for this dog, the important features, if I'm trying to decide, is this a dog or is this a cat? Right? Facebook uses machine learning to decide whose face it is. And they decide features of your face that they think are important to deciding who you are. But at the kind of, again, back to the basic level, so if we're deciding, is this a dog or a cat, it might not be helpful to say, does it have hair? Right? That's not a useful feature. But maybe leg length, maybe weight, maybe height. So you would put those 3 parameters in. It would create a formula after knowing what dogs are and what cats are. It would say, oh, if the weight is kind of this and the leg length is kind of this, then it's probably a dog. And then it would give you back a result. So I hope that kind of demystifies some of this idea of machine learning. Obviously, it's way, way, way more complicated than I'm making it. But I'm trying to boil it down to an idea. And this is what I learned at the conference. I was like, oh, wait. I can kind of see applications for that. There were 2 that were shown to us in this specific one. How good is my model? Let's say I was to put, now for machine learning you need a large data set. There were a lot of presentations with small data sets, like 8 models, 10 models. So it's doable, but your results are going to be kind of iffy if you use a small data set. So how good is my model? I might plug in how many groups I have. I might say how many instance families I have. I might say how big the model is. And then from that information, if I had 30 models like that, and I knew these ones were good and these ones were bad, then when you plugged a new model into it with those same key data points, it could tell you, kind of, yeah, it's good, or no, it's bad. And you could get more specific into that. But that would be an application. Or how much does this cost? Sometimes it takes a lot of time for us to figure out costs of our projects. And so this group developed a machine learning algorithm that would look at how much curvature the pieces had, how much uniqueness there was in their design, and then just would spit out a proximity of cost. So then the designer, when they start putting in these crazy swoops, realizes, oh my goodness, I just tripled my cost with that one swoop. If I remove that one, it might be more feasible and might actually not get V'd out later on. Other applications are things like clustering. So if you're looking at this facade, or this facade here, and you're trying to figure out, okay, which of these pieces have the most curvature? Now, I'm not telling you here which ones have the most curvature. I'm not telling you which ones are the most square, but it's grouping them based on the features that they put into it. And so kind of like, is this a cat? Is this a dog? It's not telling you, yes, these are the expensive ones, these are the cheap ones, but it is kind of telling you there's two groups. And then you could boil down into those two groups to figure out what they are. And you could see here, you could tell it how many groups you had, and it would give you a different layout. Now, how many of us, 90% of our projects, are swoopy, curvy things? Nah, not so much. And so it's like, wait a minute, Timon, you're telling me machine learning has application, but only for these kinds of things? Well, I want to pose that any of us that work on historic buildings work with swoopy facades. And there was an interesting algorithm here shown that would actually be able to find, do you see this? Find all the joints in the bricks and then be able to model the bricks individually from the facade. So using this kind of grouping idea, it was able to group, you see the red, the yellow here, the different bricks versus the mortar joints. That's pretty cool. So with that, I want to show very, very, very mini version of another kind of machine learning thing that I learned. So let's see here. Was it on a moment ago? As soon as I sat down? Anything? Well, there's beautiful squares on the screen. Are we going to get this working? I'm plugged in still. All right, well, while that pulls up, I'm going to... Oh. All right, let's play this one. Oh my goodness, this is going to be... Let's see here. I need to change this. Can I do this? Yes, great. Okay, so... Ooh, it's kind of small. Okay, so here do you see, you can't see it, so you're going to have to trust me. If you want to stand up and walk up here, you can see it. But I have these 5 or 4 different types of rooms I've laid out here. On the left side, it says bathroom, which is not going to be nearly impressive in this tiny font. On the right, it says social space. And in the middle, it's hallway and bedrooms. So these are just classifying a room by its size. Super tiny data set. This is really all I gave it, so it's really, really bad. But we're just going to see, can it guess what my room is based on the size? So, all right, what's your guess? If I draw this in here, is it a bathroom? It says, I'm going to have to read it here, bathroom, question mark. All right, I'm going to put another one on. And it says bathrooms. It's like so much less impressive. Was this zoomed out? Oh, you want me to draw a different one? Wait, are you thinking that I've just programmed it to always say bathroom? Oh, that would be pretty smart. All right, so let's try a big one here. So I'm going to draw a big one over here, and it says social space. So there's just kind of a very, very tiny, miniature example of how machine learning could help us if we were, for example, from our last 80 projects were to take every room, take the volume, take the dimensions of the sides, maybe take its level or its location, any other features we think are important to know. Maybe is there a toilet inside of it? That could be helpful for naming. And then let the computer name it based on how you've named that type of space in the last 80 projects. So that would be kind of a miniature applicable application of machine learning. So with that, I'm going to end and open it up for questions if anyone has any. And I'm not going to try to pull up the question slide. Well, we'll try. But all right, we'll just leave it on this. So any questions? Yes? Yeah. Can I cut your question off? I think you've got your question. So the question is, if I had this kind of information on previous projects, again, 80 is a very, very small data set for machine learning. We're looking, for good, really quality stuff, you're looking at thousands and thousands of projects or floor plans. And I think the question was, if you knew what floor plans looked like based on a layout, could it lay out the floor plan again? What do you think based on what we saw earlier in that other presentation? Based on TestFit, what they're doing. So TestFit's not the only player in that game right now. I saw 3 personally presentations on different groups that are doing generative design like that. So yes, definitely possible. I mean, anything that's parameter based can be converted into that way. But they're even taking basic artwork. And there are some really, really crazy things about if you just kind of started sketching, it would give you floor plans. Again, the stuff that TestFit is doing, the stuff that I saw that is coming today and is applicable, is really on either the early side, right? Is this site feasible? Pre-concept, how would my massing work? Or very specific, smaller target things. Like, for example, the rerouting of pipes. That could be something that's being solved generatively with machine learning, much, much more complicated than the way we solved it in 2 days at a hackathon. But yeah, so those kinds of things are definitely coming. And what I talked about a little bit with this idea of augmented design is the designers that I believe, I'm just going to make a proposal here, I believe that are really going to succeed in the next few years, probably 10 years down the road, are going to be the ones who understand how to define a problem and then how to select optimal solutions. The computer can provide those, but at some point it's going to be providing the same thing, and people don't want the same thing. People want something different. And so knowing how to define a problem differently is going to allow for a different result. And that's where designers are going to be kind of working with technology to create this design. I'm calling it augmented design right now. And with that, I had it earlier, but since Jeff talked a lot about generative design, I didn't cover it. But there's 2 types of diagrams I highly recommend in that space learning about. One is a spider diagram. It kind of shows optimal designs based on a circular layout. And one is called a parallel coordinates diagram. And you can look at it and Google them, look at them, learn to understand how they work, because that's how a lot of the options are currently being provided for people. So, another question? Any other questions?
If you use Kayak, you use parallel coordinates, right?
Huh? Does Kayak have parallel coordinates on it?
Yeah, when you go through and you refine your search, right? You're going through and I don't want to fly out of Dulles. I want to fly out of BWI.
Yeah, so building design is kind of in some ways taking on some of the technology things that other industries have already had, like I think you're talking about the airline industry, right? Flights. You're like, I'm going to be flying from this place to this place. That's the basic problem. But then you're like, okay, I actually don't want to fly overnight. I really want to fly on this airline. Reword that into a building conversation. I need a building that's so large. I don't want one that's over 50 feet high, and you start getting your criteria. Are you ready to go? All right, let's switch you over. I was waiting for you to switch over.
Thanks, Jim. Appreciate it. And really what he's talking about with generative design, and I think, I'm very excited about it. I think Tim is excited about it, is it's really optioneering. You're getting a lot of different options to choose from that you normally wouldn't be able to access unless you had the tools to do it. So watch for generative design. It was, I think, Jeffrey Panera, who's the Revit. Anyone know who the Revit kid is? The Revit kid, when he did his download, I was sitting with Chris at the bar earlier when he was drinking, I wasn't. But he said, Jeff Panera said one of his takeaways from the Build conference is how prevalent and how real generative design is becoming. It is really something to keep your eye out for. Here, I can back. All right. Now this is a presentation that we get all the time. Questions we get about all the time is how do you deal with shared coordinates? Because anybody that's working with a project, multiple consultants, always has to deal with this. So this is kind of some best practices we put together, and hopefully you'll walk away with something you can use. So perfect.
Hopefully. Hi, everybody. All right. So this presentation, my colleague Nick Sipes gave at the Baltimore User Group last month, and so I'm doing it here. As with anything with shared coordinates, we know that they are very finicky, and you can't always do the same thing twice. So take that with a grain of salt here. So some of the things I'm going to show you are some of the strategies that we've kind of discovered, but as with, like I said, they're not always going to work, but it's one additional strategy. So what are the coordinates? Why are they important? I'm going to talk about setting up the project a little bit, and then some common fixes as we show here. Here's me. Most of you guys know me, so I'll let you read that. All right, so just a basic overview really quick. There are 3 points right inside of Revit when we talk about coordinates. The first is the survey point. This is the point that is used to coordinate a bunch of buildings on a site. So every single different building that you have is going to have the same survey point so that you can line them all up on the site. Then you have the project base point. The project base point is the point used for each individual building to line up multiple models for that building. So every building on a larger site will have its own project base point. Like if I have building A and it has architecture, structure, MEP, those will all have the same project base point. Building B, the same thing. But then every single model will have the same survey point. So if you were to link them all together into one model, they would go in the right location. And then there's the third point, which is the Revit origin. The Revit origin, how many people know about the Revit origin? Okay, good, so it's like half, so that's good. So the Revit origin is the third point. The Revit origin is, out of these points, actually the most important, but it's invisible, and you can't move it, all right? The reason that it's important, how many people have heard of the 20-mile rule in Revit? Okay, so the Revit origin is where that comes from. So the Revit origin is the 000 point for your graphics in Revit. So the reason why when you model something really, really far away from the Revit origin that the graphics start doing weird things is because it's just too far and it can't process it and it's really, really far. So the most important thing is to make sure that whatever you're modeling is near the Revit origin. Okay. When you start a Revit model from the out-of-the-box library template, the 3 points are right on top of each other. So that way you know where they are. If you ever lose your Revit origin, not sure where it is, you've moved your other points, if you link in a CAD file origin to origin, it will put that CAD file at your Revit origin. So that's how you can find it and know where it is. So the real lesson here is if you ever get a file, like a civil file, and you link it in origin to origin and it shows up way out in space, don't model over there. It's not a good idea. because it's just going to be too far. And it's not even 20 miles. I actually did a whole, went down a rabbit hole once trying to figure out like where the graphics do weird things. Literally like 4 hours later, and I still was like, this makes no sense at all. I wrote a blog post about it. You can go find it. But like, it really, the lesson is just don't model all the way out there. Model close to the Revit origin, because what happens is your drafting patterns start doing weird things. As you zoom in and out, like lines will just kind of jump around because it just can't process that far away from the Revit origin. And it's really only like a mile or two. It's not really even 20, just based off of my own personal testing. So all of that's there. Initially, when you set up your model, typically the architect owns the points. I typically, in all of the templates that I set up, I will actually place 3 reference planes to mark the X, Y, and Z of the Revit origin. I'll make, starting in 17 or 18, you could make like subcategories of reference planes. So I make one called the origin. I make it bright pink. I put the 3 reference planes in X, Y, and the Z, and I lock them. And I tell everybody place a locatable point of your building on this spot. So I'm marking that Revit origin, telling people to build there, right? So you place that spot there, somewhere on your building. Usually it's the intersection of 2 grids. If it's an existing building, you might do it at the corner of the building, a spot where you can actually find. And then again, moving the points. If you are only working with a single building, don't move them unless you really have to. We're going to talk about northing and easting in a second, in the same point. And if you're doing a multiple building, you're going to have a site file and then use that to kind of publish the coordinates to all of the other buildings. Okay. So now the fun part, Revit demo. All right. So now I'm going to sit down because it's a little bit easier. Okay, so here I have a file. This is a little building. If I go here to my north elevation, you're going to see that my first floor is set here at 340 feet. When you're going to be, so what I'm showing here is I'm showing that you're going to take a point on your building that you've gotten from your civil engineer who has located the building relative to where it is on the planet, right? Because that's always the issue that we have is in Revit, the world moves around our building. It's not really located where it is in the world, whereas civil engineers locate the building where it is on the planet, which is how it should be, really. So what we're going to do is we're going to take a coordinate point given to us by our civil engineer of a specific point of our building, and we're going to use that to orient our building. So in order to help us do that, our building is up here, and then I have a sea level elevation marked as my 0, 0. We need this 0 level for topography, right? We know that topo always comes in relative to the 0 of your building. So part of this is going to show you how to bring in topo also. So we have this 0 level kind of to be the 0 of our building. And then here I have the building located here. All right. So I'm going to go to my plan that is my site plan view. I have a text file. This was given to me by my civil engineer, giving me the northing and the easting for my building, along with the elevation that my project base point is going to be set at, and then my angle to true north. So I'm going to take these values, I'm actually going to put them into Revit. So I'm going to copy this, right? Now something important to note is here I have my project base point and I have my survey point, and they're here on top of each other. Now my survey point is set at 0, 0, 0, okay? And then my project base point here is actually set to 0, 0, and then it has an elevation of 340. This was just to kind of show you, this was sort of to mimic like a real world type of example where the architect may have already given the building an elevation, and now the civil engineer is saying, well, actually it's a little bit different, so now we're gonna update that, okay? And this is a different workflow than anything that I've used in the past, and part of this is because being able to get this information is relatively new, so it's kind of an update to the workflow that we've used in the past. So I'm going to go here to my Manage tab, go to Coordinates, and I'm going to use the Specify Coordinates at Point. Has anyone ever used this? A couple of people? All right. If I'm doing something wrong, you can tell me. specify at point. All right, I picked it. I'm going to choose this point right here, and it's going to give me this window, give me those points. Okay, so I have that north-south one. I pasted that there. Go back here, copy that one, paste this one here. This is 344, and this is 249. Now, something interesting you'll notice here. I type in this 249, okay, and then I click away. It changes it to 111, and it actually changes this to west. You actually have to go back here and change it to east. We're not sure why. It's not actually documented anywhere that we know of. Do you know why? So I have the survey point unclipped right now. Yes, I have it unclipped right now. So it's going to move with it. So I put that in, now. So when you type in the angle, it's going to switch to west, and you have to just switch it to east, otherwise it will rotate the wrong way. And it's just a weird thing that we figured out as we were putting this together. There you go. Yeah. Nick figured this out, and he's like, and I couldn't find it documented anywhere that you need to do that. Just from testing it, he figured this out. So now I say OK, and it rotates my building. Cool. OK. So now I've got my building. It's actually set properly. One thing I forgot to note, so my view is set to true north. You want to make sure that when you do this, that your view is actually set to true north, because that's what you're doing, is you're rotating the true north. So if I go here and I change it to project north, I'm going to see that it rotates back to the way that it was. Okay, pretty cool. Now, we haven't yet figured out a way to consistently to push this back to the links. So the recommendation that I'm giving you right now, which may change, is to have all of your consultants do the same thing. Specify the same coordinate, give them this coordinate, tell them specify this at this point. And once they do that, and then you link them back in, they'll all be in the same spot. The one other thing that you'll have to do, though, before you send it out, is because we changed the elevation of the building, we're going to have to go here to elevation, and this actually got moved up 4 feet, the sea level. So we're going to change this back to 0, and we're actually going to change our survey point back to 0, and then we're going to clip it. So now our survey point elevation is at 0, and our sea level is at 0. Okay, cool.
How often would you say you get those points from your consultant, your civil consultant?
I would ask those out there, because I don't know. Did you have a question? Oh. Yeah, I've been trying. I was trying to make that work, and it wouldn't actually do it, because here's the issue. Typically, like, I've given my model to my consultants, right? They link it in, they acquire the coordinates from my model, and then they start working. So when you try to reacquire them, it tells you that it's already acquired, and it doesn't work. The solution would be to unlink it, like to remove it and link it back, but that's not usually what we want to do, because a lot of times consultants are dimensioning off of the links, or somehow their objects are referenced to the links, and so removing it and putting it back isn't always the best solution. I tried that too, and it didn't work. So it's still in testing. This is still in testing workflow in terms of using it like in real life and not setting it up perfectly from the beginning. So that's why I'm saying kind of take all of this with a grain of salt, and kind of the fact that coordinates are just confusing in general. Did you have another question?
Actually, my question was even going further. If you acquire from a file and that file change, is it going to be dynamic? It's going to be changed accordingly?
Well, so what ends up happening is if I have this architecture model linked into a structural model, and I open my structural model is where it is, and the architecture model is like all the way out here now. So I have to do the same thing to the structural model, and then they get aligned again. I have to use the same specify at coordinates at point. And then they line back up together. I'm going to do that next. Okay. Yeah. Will it all be together instead of out in space? No, I'm going to show. Yeah, I'm going to show you how that connects it back. Yeah. That's okay.
Elevation to be at a particular level, and it changes by a relative base point of phrasing the term.
You mean relocate project?
The same thing we did, like specify coordinates. If you click a level, you can define what level that is supposed to be at. So is there a difference between specifying survey point, project base point versus specifying the elevation of a particular level for the project point?
I don't think I understand your question.
The difference between I believe, the project base point and the survey point, you can switch on the level, right? Like the annotation of the level.
Oh, yes.
I think that's what he's referring to.
You mean the...
You wouldn't want to change, like move your whole
Oh.
building up that way. That would, like moving your model elements, that would be a nightmare.
Yeah, no, I wouldn't move it. So really what you're doing, we're doing a similar thing to the relocate building tool, where we're keeping the building where it is and like moving the world around it. Like that's how Revit works. That's why all of your annotation doesn't get messed up when you use the relocate project tool or when you use this, because it's literally like moving the world around your building. Does that make sense? So all your sheets don't get messed up. I don't know what happened over there. So.
When you did specify coordinates at the point, what did you select after you?
I selected right on top of, it ends up selecting where the project base point, essentially.
So you didn't specifically select the project base point? I'm just wondering how you, what elevation, since you're picking a point.
When you pick the point, it picks the project base point. Like I picked it on top of the project base point, so that's what it picked, was the elevation of the project base point. Yeah. Do you have a question in the back?
Yes, but if you have linked an architectural into, say, an MEP, and you have kindly monitored the levels, if the architect changes the levels, wouldn't you just do a coordination review and it would correct it?
Change the levels?
Yeah, you said you're moving your level, building up. Wouldn't just doing a coordination review fix your model?
I'm actually not sure. I'm not sure if doing just a coordination review and then accepting the changes would actually fix it or not. That's a good question. That's not something that I've tested with it. But what the workflow I would say to do would be that before you link in the new architecture model, you would do this same process with your model and then then reload the link, and then they would be in the same spot. Does that make sense? And again, that part, the pushing back part is a little bit where it gets a little hairier in terms of working properly. Okay, so I did this. Then the structural model, we did the same thing too. And so then when you link that structural model back in, it's going to be in the same spot. I do want to show you now that we've used that point to specify where the architecture model should be, we can now actually link in the Civil 3D file. So I'm going to go to Insert and Link CAD, and I have this is that site file. I'm going to uncheck the correct lines that are slightly off axis just because it's a big site file. I don't want it to mess up any of my information. And then I'm choosing by shared coordinates, okay? And I'm saying orient to the view. Okay. So this is a really big file, so you're going to get that typical, like, it's too big. And then there's, ActiveX stuff. This is the interesting thing that happens. So it's telling you that that your model and your CAD link don't have the same coordinate system. So what do you want to do? Usually when you do that, it just tells you that like it can't do it, but you actually have this option here to align it. So if you hit this align tool, it actually puts it in the right spot. Right, pretty cool. And then I can, for some reason when I try to link the CAD file in and it's set to True North, it doesn't show up. So I set it to Project North and do it, and then I can set it back to True North if I want. I'm not quite sure why. Nope, because I used the point that the civil engineer gave me at this point of the building, and I put that same point there, so they're coordinated together. Yep. It's true, and so the interesting thing is my coworker, when he did this at Baltimore, there actually was a panel of other AEC professionals there, and one of them was a civil engineer. And so the civil engineer actually said, Like, I can give you this point. It's not hard at all. We can coordinate this, right? So the civil engineer said this. Like, it wasn't, you know, it wasn't the architect saying, like, the civil engineer can do this. It's the civil engineer saying, yes, I can give you this point. If we coordinate this point, I can give that to you, and then we can make our models coordinated. Now, the thing I do want to show you, that I want to show you here, though, also, before we move on to the next thing, is that I did not move my Revit origin. Okay, and I'm going to show you how I know that. I'm going to go ahead and I'm going to link in a CAD file. I have a little CAD origin file that I've used in previous presentations. I'm going to make sure that I link it in origin to origin, okay? And then I'll place it at sea level, that's fine. I'm going to go ahead and say open. Okay, let me do this so you can see a little better. It's my little Waldo. And this is I brought it in right at the origin. So you can see that the Revit origin did not move, right? Even though if I click on the project base point, it has these values that I put in that I got from the civil engineer. So I'm good. I can model around here. It's not going to mess up any of my graphics. I'm still at my Revit origin, which is the important thing. Okay, the last thing, two really quick things. I have like 4 minutes left. I am going to put this back. Okay, so the next thing is that and then this is the other thing your civil engineer can give you. If you want to get more accurate topo, you can get from your civil engineer a land XML file. And the civil engineer at the other presentation said, yes, I can give this to you. It's very easy. It's a very easy export for me from civil. You have to have the site designer plugin, like the site designer plugin, otherwise this is not very good, but it has this one little tool. So it's free, you can get it, I would use it. There's this button, import land XML. So my civil engineer has given me that land XML file. I'm going to hit import. I'm going to choose where I want to get it from. I have this topo file, okay. I say open. Now remember, the civil engineer gave me this, so it has the same coordinate system as my file now and as his CAD file does. So I can say open. I'm going to choose to enter it in by survey point. I'm going to say OK. It's going to give, there's like one, you can have multiple topo surfaces inside of a land XML file. There's just one in here, so I say OK. I can choose what phase I want it to be on, and I can give it a name if I want to. If I have a topo already, I can choose to overwrite it. Say OK. It says it has no alignments. It's fine. It works. Done. And I have a topo. Now you'll notice that the lines of the topo are slightly off from the line of the CAD file. That's because the topo is an actual surface. It's a TIN from the civil file. So if I go and look at it in 3D, I have something else linked in here that makes it go out into space. And that was how easy it was to make my topo surface. Like literally, I just made it from that land XML file. Right. So I can get it directly from my civil engineer. So it's a real civil surface. It's not me extrapolating it in Revit. Okay. And then here's the other cool thing. You can actually take your model and you can export it out and insert it into Navisworks. You link it into Navisworks. And you can't bring a Revit file into AutoCAD, but you can bring a Navisworks file into AutoCAD. So you can take your model and give it back to your civil engineer, and they can put it into their model using a Navisworks file. So to show you that, here I have that same site file that my civil engineer, this is the file I brought in, but say this is my civil engineer's file. I can go over here, and I can attach a coordination model. All right, I have this NWC file that was created. I exported my Revit out. I put it into Navisworks. It's all, the shared coordinates are the same. I'm going to go ahead and say open. I'm going to make sure that I'm not specifying on the screen. I'm letting it do it on its own. And there's my building right there. And my building is in my CAD file too. Right, so it can go back. So you can now give your civil engineer your building. Pretty cool, right? And I think that's all I have. So. Cool. Any last questions? I don't know. I think I have no minutes. It's 7:30. Richard's turn. One last question?
Anybody else? Any questions?
I'll just say I've used the process quite a bit.
Mm-hmm.
And sometimes when I have issues bringing the CAD files into Revit, if you change the import units from auto detect to meters or feet, whatever the CAD file is in, it'll work.
It'll work better. Okay.
It didn't elsewhere. I don't know why, but that's just one trick I've
Oh,
used.
good. Well, that's good to know. So everybody, if you have any issues, make sure you specify the units. Should work better. Cool. For the bringing the CAD into Revit, you said? Yeah.
Okay. Thank you, Purvi. And now we're going to hear from Richard, and this is, I think he's gonna embarrass me here in a second. But Richard gave this presentation at Build Conference, and I sat in on the presentation thinking that, oh boy, I'm going to be about 5 minutes in this thing and running out the back door. But actually, when I saw the presentation, it was really it was interesting. I really thought that, this is something that in your days of using models and using Revit, you're not going to run across this and know this. And I think Richard came up with a couple different examples about how you'd be using this information or where it is. And so for those of you who have never opened a journal file, you're about to see what's in one, and you're about to see a couple examples about how it can be used. Did you have a comment, Dana? Okay. So, you up and going yet?
Yeah, I'm good.
Okay.
Can y'all hear me?
So, let me turn you on here. Get you. Yeah, there you go.
How about now?
Up a little bit. Okay.
How about now? Yeah.
All right, perfect.
All right.
Thanks, Rich.
So, thanks, Jeff. It's quoted here for what are Revit journal files and why should I care, as he asked me when I told him I was going to present this. I'm a BIM technologist at Smith Group, and so we're going to talk about what's inside the Revit journal file and why it can be useful for your firm. How many people know that they exist, that there's a file that Revit makes called the journal file? Who's ever tried to read one? You're still with us, that's good. They are difficult to read. They can get really, really big, very large files. So having some guidance for what you're looking through can really be helpful. I started looking at them because when I joined Smith Group, we were having crashes for certain issues, and we were able to track it down by looking at the journal files, and it led to some clues as to the issues we were having. And it's going to be a lot of looking at text files, so I'm sorry in advance. There's only one way to show how to look for things in text files. But because of that, I made something for my firm, which I'm going to touch on briefly, and we can take a look at the end. This presentation is mostly going to be about just what's in journal files. But I made a application for scraping journal files, aggregating that data together so that you can see the action of your firm over time. So this is 20-something users inside 5 different models over a week. So you can see the additions, the modifications, deletions, warnings, synchronizations, all that information that people really want to know when you're operating a really high-capacity firm like Smith Group. We have 1,500 people at our firm, so there's a lot of bandwidth going on. And so we'll take a look at that at the end. First I had to understand what was in journal files, read a few hundred of those, then manipulating C# to build an application that can read and write text, injecting information into the journal file from Revit, as well as then building a application using the web with D3, which is a data visualization library for JavaScript. So what is a Revit journal file? It's a text file written by the Revit application. It records all actions by the user, but it's from a UI perspective. It's not saying, you know, I picked up this particular wall and changed its color to this color. It's, I clicked here on the screen and changed a parameter here on the screen. Maybe it'll tell you what element it was. It sometimes won't, most of the time it won't. It lives in your local app data folder. If you don't know about the app data folder or the program data folders, that's because Windows hides them from you automatically. You can go into your folder options and turn on hidden folders, or if you type into your file explorer %, and then local app data %, it will auto path to your user's local app data folder. So let's dive into some text files. There you can see the folder. It's, they're given a specific number, and that's tied, each file is tied to a unique Revit session. So there can be many models, many families that are open during that session, but each time you open a session of Revit, it creates a journal file. The basic structure of these journal files is that there are time-stamped log events. So you can see those '(C), and it gives you the date down to the microsecond. That first action there is starting to record the journal file, and then initializing applications, getting licensing info. So it really describes the process that the application is going through in the background, as well as the user actions as they manifest. You can open these up in Notepad, but it's easier in Visual Studio Code, which is a free application that Microsoft puts out for web development. The benefit here is you get line numbers. So for a 10,000 line text file, it's easier to get around. There's also that sidebar, which is really nice for seeing the overall length of a file and getting some perspective on where you are in a really, really long text file. You could scroll through these looking for things, but it's a lot easier to use Control F to get your way around. So some examples of some things you could look for. If you want to know what release of what version of Revit is being used. Flagging that keyword, you can see that this was 2019. You can track down the username. That gets flagged a lot of times in the file. So you can tell who was working in that session of Revit. You can get operating system information. One statistic that I'm tracking is how much free memory you have, because there's a line for Revit. It's 16 gigs per file that you need of RAM, but that increases as you nest files. So seeing where you're at in terms of capacity can indicate whether or not you're having issues caused by a lack of RAM. You can look at processor information and video controller information. A lot of times we'll have issues in Revit where the user's machine is stuck on the graphics card that came on the processor in their laptop rather than using the actual GPU. It can cause crashes in Revit, but switching it to the right one or being able to know it's on the wrong one can correct that issue quickly. You can see what files a person opened. So here you have a basic command. So instead of the '(C), '(E), and then it's telling you that in the ribbon, somebody clicked the Open an Existing Project button, the ID Revit File Open button. And so opening a file can happen in many different ways. If this was from the recently used or recently opened files, it would give you a different string of characters up there indicating that that was what happened. And if you search for basic file info, it'll give you lots of information about where that central file location is, how it's being hosted, and other information about the file that's being opened. The tricky thing with that is this information differs whether it's hosted locally on BIM 360 or on Revit server, or if it's not even work shared. So the formatting of that can be very highly variable as well. When a user changes what view or what document they're working on or what model they're in, it'll always tell you that a different view has been activated in a certain model. So the first one that gets activated is our start screen and then in that particular model. But as you move to a different floor plan, it's telling you that that view is activated. So you can track in what model in the session the person is contributing actions. Indentation in the file is indicative of nesting. So as you go into a link and then you go into a family that's inside of a link that has a warning, you can get several tabs in. So the furthest tab in, it's you're getting warnings about a room in a linked model inside of another linked model. So very useful stuff, or not useful at all. Speaking of not useful stuff, 90% of all the journal content is mouse actions and Revit regenerating the image. So all of these project to page is it redrawing what you're seeing. The mouse move that's highlighted is saying what point on the screen did you move to, or maybe actually it's probably a vector of where you move from and where you move to. And then someone pressed a key and keyboard shortcut initiated, and you finally have something starting to happen, even though it's just another zoom to fit, so it initiates another projection to page. You can see transactions. So Revit transactions are any time the database that is the Revit model is modified. So when there's additions, parameter changes, deletions, the only trouble is that you can't tell exactly what it was. Like here is highlighted a successful transaction of creating similar. You don't know exactly what. You know it's a pipe, but you don't know what type of pipe or an element ID of that pipe, or even the parameters that were copied over when you did the create similar of that element. So if you search for 3 exclamation points, capital BIG underscore GAP, you can see when Revit admits that it wasted a bunch of time. I want to get like a year's worth of data on this and see exactly how much time they've admit to wasting of ours. But that's just a fun anecdote, though. But that 14 seconds, that's a long time to just be sitting there doing nothing. There's fun little tidbits from Revit developers. So if you see debug info, it usually points to somewhere in their script or their code where they're having some issue that they want to communicate to themselves. The Revit journal file was originally just for development. It got left in by accident, and they decided that it was useful for troubleshooting things with users, so they kept it around, but there's a lot of this stuff. A lot of this stuff is probably old, too, and no one's ever just gone back and cleaned it up. But you can see it finding an element, or not finding an element, which is actually a considerable issue. That last line down there, when constructing element record, element whatever was not found. If you accumulate too many missing elements in your model, it will go corrupt, and then you actually have to send it to Autodesk to fix that for you. Or we get to. I don't know if everybody gets to. Debug warn is another warning from the developers. You can see this one complaining about attempting to get an outline of a dirty view, which I don't know what that means, but the one up top is saying that it's already cleaning. Please ignore this message if in the middle of crash protection. But, good to know it's already cleaning. So the end of the file, which is useful to know, because if you don't see this information, it means something happened to the session and it didn't close out properly. So you can go back to journal files. See, I'm I'm scraping them after they've already been created and the session is closed out, so you can go back to them and see whether or not they ended correctly to determine your rate of crashes. But you get some summary information there, and then it always ends with the finished recording journal file line. When looking for specific behavior, the best way to track down what you're looking for is by doing things side by side and comparing the journal files. So I wanted to see when someone was auditing files. So it's an important thing to do to your models is to audit them regularly, but it doesn't happen often, unfortunately. So I opened a model, regular way, didn't audit it, and I got the top. And then immediately closed the session, have a tiny little journal file to look at, went back, opened the same model, opened it the same way, and decided to audit it. And you can see the pieces that show up that didn't show up before that are pretty deliberate. So you see that I opened a file dialog and checked a box for audit, and then the task dialog result was a yes. I ignored its warnings that this operation can take a long time. So it's a little tedious to go through and have to go back and forth like that, but that's the best way I've found of isolating particular behavior that I'm looking for. So I presented a version of this presentation at Built where I went into a lot more detail about coding and using C# and JavaScript. I'm not going to put you through that. I think that's not what this user group was meant to do. But this was my fun slide to get them excited about reading more text files. It's built off of text. I mean, all of code is. So there's quite a bit of C# and JavaScript and a little HTML and some CSS that went into the applications that I made. The first version of this, I just wanted to see if I could do it, was to just take one journal file, so one user's activity, and break that out and be able to read through it. So you have a time-based graph with different categories of events, a little summary bar graph per model, and then a data table at the bottom that is just a chronological list of these events that you can scroll through and then select different items. The second version that I'm currently working on is multi-model, multi-user. So being able to scrape a collection of journal files or to put them in a database and bring out a set of that to view multiple users across multiple offices' activity. The architecture of this is a little more complicated for so there's an add-in inside of Revit that's kind of populating elements into the journal file that I want to pick out. Then after Revit is closed, the scraper initiates itself, can either send that to the database or just read the file. The application itself is a Windows exe that has a Chromium WPF window that then has a Chromium browser nested inside that that shows this D3 visualization. So I'm going to go ahead and show you that. So this is where it's at now. So you can zoom into the day and see the 70,000 plus events that happen throughout the day. Hover over different pieces and see what happened in a particular model. Get a readout of the message that was accompanied that. Let's see if I can find a better one. There's a big gap, another 14 seconds. But you can begin to see lots of interesting user activity, just patterns. Like you can see when lunch happened. You can see that somebody made it home and was still in a model. You can see who gets in early. You can see who spends their day nudging things around on a sheet, and the person who line works everything in everyone's models. So it's a pretty useful data set. We still don't really know exactly how we're going to use it. This is more of a proof of concept right now, but that's jam. Yes.
So could you count how many times you use it in certain activities?
Yeah.
Put that into like a clustering machine learning like we were talking about? Come up with like the 8 users that need the most training potentially?
So I think because it is human behavior, it is actually more applicable to machine learning purposes. It's a record of activity rather than designing a building, which is more explicit. So it's pattern-based rather than a building has to be built within very specific constraints.
Is the journal file just recording actions, or can I use it to find elements in Revit also that we can't inherently figure out where they reside?
So if you can make a C# application to run inside of Revit, then you can inject whatever you want into the journal file if that's where you want to look for it. You have a direct connection to the journal file that you could insert information to if it's not already in the journal file itself.
Have you attempted to do something like that?
A lot of this relies on it mainly because of the inconsistency of the formatting. I was like, if I open a model, I want to see that happen in this way, and I want to know these things about it. So I just stripe that out into the journal file and have a specific line that I'm looking for rather than trying to find it in a bunch of different formats.
But the journal file is not injecting that information right away unless you tell it to?
It does, but it's just
really hard to find?
It's inconsistent a lot of the time. So.
Because I always have these situations where like people import like everything in there, and for example, I have like an annotation symbol, 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 and I'm like, where's all these symbols? And I'm trying to find where they are and try to like purge it or at least rename it so it's like more identifiable.
For things like that, the import will definitely be, the import action will be there, and it should tell you the name of that family as it came in too.
Do you have any keywords I can?
If you look for the import, that'll give you the event that happened in the file for sure. Okay. And then could be within 100 lines of that you find what you're looking for.
I have a lot of time right now.
Anybody else? Any more questions? Go ahead.
So just to clarify, you said that you made an add-in in C# and you use it to inject data into the journal file, like an element ID?
Yeah.
Okay. And what is the advantage of doing it the way that you did it here as far as the visualization or as opposed to like Power BI?
That's a good question. Power BI is less customizable than what I did here. From an application level, I feel like I can really fine-tune this, but that's because I have the programming ability. Power BI makes data extremely accessible. You could, the JavaScript and this visualization part is probably one of the harder parts of the whole process. So if you make the thing to consume it and turn it into a standardized data set, Power BI is a great option for working with that data once you have it.
All right. Any more questions?
I have one more comment about, I forgot about this, but Timon was talking about Rhino Inside, which McNeil released to build a Rhino application on top of Revit, so you could use Grasshopper in Revit. It is possible, but someone has to make the connection between Rhino Grasshopper's geometry and Revit's elements. That isn't connected. You can run the applications together. You still have to build that link between how a plane in Rhino becomes a floor in Revit. That's not there. You have to build that, but it is possible. It's extremely powerful stuff, and it's awesome what they're doing with it. But thank you.
Super. Thank you. Thank you, Richard. Thank you, everybody, for coming out tonight. We'll see you again in October. Please fill out your surveys. Anybody wants to present, please get in touch with us. The board will be meeting in the next week or so to choose the October meetings. Thanks again, and have a good evening.